Good day to all. Today we are going to see graph theory and its applications. Contents, introduction, basic definitions and applications of graph theory. First of all, we are going to see what is a graph. A graph is a data structure that is defined by two components. First one is a node or a vertex and second one is an edge. Edge is an ordered pair. It is a connection between two nodes UV that is identified by a unique pair UV. The pair UV is said to be ordered because UV is not same as VU in case of directed graph. The edge may have a weight or is set to 1 in case of unweighted graph. The diagrammatic representation is shown in the figure. Here the alphabets A, B, C, D, E, F are the vertices and the lines joining the alphabets are edges. Next one is 7 bridges of Koenigsberg. In Koenigsberg, a river ran through the city such that in its center was an island, and after passing the island, the river broke into two parts. 7 bridges were built so that the people of the city could get from one part to another. A crude map of the center of Koenigsberg might look like this. The people wondered whether or not one could walk around the city in a way that would involve crossing each bridge exactly once. In 1735, a Swiss mathematician, Leonhard Euler, solved this problem. He provided a solution to the problem and finally concluded that such a walk is not possible. Euler represented the given situation using a graph as shown here. In this graph, the vertices represent the landmasses and edges represent the bridges. The diagrammatic representation is like this. Euler observed that when a vertex is visited during the process of tracing a graph, there must be one edge that enters into the vertex and there must be another edge that leaves the vertex. Therefore, order of the vertex must be an even number. Based on this observation, Euler discovered that it depends on the number of odd vertices present in the network, whether any network is traversable or not. Euler found that only those networks are traversable that have either no odd vertices or exactly two odd vertices. Next, we are going to see some basic definitions of graph theory. First one is a null graph. A null graph is a graph in which there are no two edges between its vertices. A null graph is also called empty graph. The diagrammatic representation is shown here. Next one is a simple graph. A simple graph is the undirected graph with no parallel edges and no loops. A loop means an edge with identical ends. This one is the diagrammatic representation of a simple graph and a non-simple graph. Next one is a degree of a vertex or a valency of a vertex. The degree of a vertex of a graph is the number of edges that are incident to the vertex. In a multigraph, a loop contributes 2 to a vertex degrees. This diagram represents its vertex degrees. Vertex degrees are notated inside the circle. Next one is an undirected graph. An undirected graph is a graph whose edges are not directed. A directed graph is a graph in which edges are directed by arrows. Next one is a complete graph. A graph in which every pair of vertices is joined by exactly one edge is called complete graph. Or in other words, we can say a graph is complete if any two vertices have an edge. It contains all possible edges. A complete graph with n vertices contains exactly n C2 edges and is represented by Kn. The diagrammatic representation of a complete graph is shown. A connected graph. A connected graph is a graph in which we can visit from one vertex to other vertex. That means between any two vertices there is a path. A disconnected graph is a graph in which any path does not exist between every pair of vertices. Here we are seeing the disconnected graph. Next one is a regular graph. A regular graph is a graph in which degree of all the vertices is same. If the degree of all the vertices is k, then it is called k-regular graph. Here the two regular graph is shown. Next one is a cycle graph. A graph with n vertices and n edges forming a cycle of n with all its edges is known as a cycle graph. A graph containing at least one cycle in it is called a cyclic graph. In the cyclic graph, the degree of each vertex is 2 and is notated by Cn. This is an example of a cyclic graph. Here all the vertices have degree 2. Next one is a tree. A graph which does not contain any cycle in it is called an acyclic graph. The diagrammatic representation of a tree is shown here. Next one is a biparted graph. A biparted graph is a graph in which the vertex set can be partitioned into two sets such that edges only go between sets, not within them. A graph is called a bipartite if its vertex set can be decomposed into two non-empty disjoint subsets in such a way that each edge has its one end in one set and the another end in another set. Such a partition is known as bipartition. This diagram shows the bipartite graph. Next one is a complete bipartite graph. A complete bipartite graph is a bipartite graph in which each vertex in the first set is joined to each vertex in the second set by exactly one edge. A complete bipartite graph is a bipartite graph which is complete. This diagram is a complete bipartite graph. Next one is a weighted graph. A weighted graph is a graph whose edges have been labeled with some weights or numbers. The length of a path in a weighted graph is the sum of the weights of all the edges in the path. This one is a weighted graph. Here we have the path. We have more path. First we consider a one path from A to B, B to C, C to D and D to E, E to G. The weight of this path is 5, 4, 5, 6, 5, totally 25. Next one is applications of graph theory in web page search. In web search engines such as Google, Yahoo, Bing and others. It searches for web pages or linked to each other on the internet via hyperlinks. In graph theory, every vertex represents a separate web page and every edge represents a link or a hyperlink between two pages. Here, the edges goes only one way, so this graph is a directed graph. The algorithms PageRank and Googlebot are used to help the connectivity process. The graph connects web pages and sites, which helps to rank pages and enables Google to display the best page. Some websites receive a large number of incoming links, whereas many receives very few. This is the fundamental concept that Google employs when sorting search results. Websites with more incoming links are considered to be of higher quality and appear near the top of the search results. Here, a simple idea from graph theory, the PageRank algorithm helped Google outperform other search engines. Next one is in social media. One of the most common example of graph theory in everyday life is social media. In social media, the concept of graph theory is widely used. Graph theory applications are used connecting friends on social media. Users in social media sites such as Facebook, WhatsApp, Messenger, Twitter, Google+, etc. are linked through a large graph. Here, people or users are represented by the vertices, and any connection between the users such as followers, friendships, likes, etc. are represented by the edges. Graph theory is used in connecting with people through a viral video. Each user is a vertex. When users connect, they form an edge. When a video reaches a certain number of connections or views, it is said to be viral. Next one is in Google Maps or Yahoo Maps. Graph theory is applied to use GPS to find a route based on user preferences or to find the cheapest fare between two destinations. In this case, the locations are represented by vertices and their connections are by edges that contain information such as distances or fare. Based on the user settings, the software evaluates the critical path. Application of graph theory in real life. We are unaware that we are employing graph theory in our daily lives. Graph theory is used in so many of our daily routine activities like ideas, concepts, operations and process in everyday life. We know that everything in our world is interconnected. For example, cities are connected by a road or rail or air networks. Hyperlinks connect web pages on the internet. Graph theory can assist engineers and other professionals who want to analyze, comprehend and optimize these networks. Graph theory is almost every area of interest and for many reasons in day-to-day life. Graphs are used in variety of fields including medicine, criminology and even as a simple teenage problem of spreading rumors. Graph theory is used to clear roadblocks. When a city's roads are blocked due to ice, the city plans to salt the roads, but advanced planning is required to put salt on the roads. For this, we can use Euler paths or circuit to traverse the street in the most efficient manner. Another application of graph theory is to develop routes. With the help of graph theory, a school administration plans to develop bus routes to pick up students and deliver them to school. Here, each stop is represented by a vertex and the route is by an edge. In this case, we use Hamiltonian path to represent the efficiency of including every vertex in the route. With the help of graph theory, when visiting a water park, a theme park, or a zoo, we can plan an efficient route to visit a specific attraction or all of the attractions. Every vertex in the graph is represented by a Hamiltonian path or a circuit. Next one is in GSM mobile phone networks and map coloring. All mobiles connect to GSM network by scanning for nearby cells. For any GSM mobile phone network, the vertex coloring algorithm can be used to allocate at most 4 distinct frequencies. Only 4 frequency ranges are sufficient to operate GSM because according to vertex coloring algorithm, the map of cellular regions can be properly colored by using only 4 different colors. This is an 4 color theorem. Thank you.